we have. So now we are going to compare the different tuned amplifiers, whatever we have studied. So we have studied three types of tuned amplifiers: single tuned amplifier, double tuned amplifier, and stagger tuned amplifier. So first number of tuned circuit, single tuned amplifier consists of one LC tank circuit, or it is called as one LC tuning circuit. Okay, so single tone amplifiers will have this characteristics. Double tone amplifier, at the we'll have two tuned circuits, so necessarily I have to use the transformer, two inductors, and across the primary I'll have one capacitor, across secondary I'll have one capacitor, and output of the secondary is connected to the second stage. But here for single tune I need to have either a coupling capacitor, or I can directly connect the output of one amplifier to second amplifier. But here transformer will do the job of connecting first stage and second stage. But since I'm going to use a transformer for coupling the two stages, they are going to be completely isolated. The transformer will act like an impedance matching device, and it will isolate your two stages. So the two stages will become, they will act independently. And stagger tuned amplifier is going to be number of single tuned amplifiers in cascade with different resonant frequency F naught. Okay, I am putting a tilde symbol, which means that the resonant frequencies are not exactly equal to F naught. They may be slightly below F naught, or they may be slightly more than F naught. So in single tune amplifier, how many ever stages you have, all the stages will be tuned to the same frequency. It is called as synchronous tuning. Synchronous means they are just like how you have studied about synchronous counters and asynchronous counter. In synchronous counter, you told that all the flip-flops will be excited by the same clock. So same way here, synchronous tuning means all the single tune amplifier stages will be tuned to the same frequency F naught. In double tune amplifier also, how much ever stages you are going to have, you are going to tune them all to the same frequency F naught. So the bandwidth is also going to be same for each stage. But in stagger tuned amplifier, the successive tuned circuits are tuned to the different frequency. They are not tuned to the same frequency F naught. They are slightly deviating from F naught. That principle is called as staggering. Okay, so that principle is called as staggering. So stagger tuning. So in single tune, we call it as synchronous tuning. In a stagger tuned amplifier, we call it as stagger tuning. So 3 dB bandwidth provided by single tune amplifier is very, very narrow because it is going to work only at one particular frequency. So the gain is going to be large, my bandwidth is going to be less. So bandwidth for a single tune amplifier is going to be very, very less. When you compare single tune amplifier with double tune amplifier, the bandwidth is going to be slightly larger when compared to single tune amplifier. We have told the reason why yesterday. It will have a slightly flat response, and the edges are going to be very steep. So the flatness in response will lead to what is called as increase in bandwidth. So when you see here both the diagrams, since the bandwidth is increasing, definitely the gain of double tune will be very, very less when compared to the gain of single tune amplifiers. And in stagger tune amplifiers, we have theoretically it is stated that the bandwidth is root 2 times single tune amplifier. So it is all the results you compare with single tune because all the circuits are framed keeping single tune amplifier as your reference. So single tune, the bandwidth is very, very less. Double tune, it is more when compared to single tune. And in stagger tune, exactly it is going to be root 2 times the bandwidth of single tune amplifier.